So I'm just coming into work now. I have a new package I just got. So this is an Armaton Chameleon mini quad, if you're into those kind of things. So it's quadcopter. So what I thought I was going to do with this is I want to do a little bit of a, well, I'd say a video tutorial, but it's not really that because I don't really even know, how it's going to come out. But I thought I'd use this as a reason to do another composite video and show everyone how to do possibly a wet layup and with a vacuum bag and compression molding, anything else that we might go along with that, right? And then on top of it, then take the chameleon frame here, which if you look at that, it's about 4 or 5 millimeters of solid carbon fiber. Go through maybe a little Fusion 360 exercise, show you the model that I come up with, and then take it to the mill and cut it out, the composite that we make, right? So a little bit of reverse engineering and a little bit of composites, a little bit of CNC, and then maybe even a little bit of flying it. So that's coming up. So this is the kit. You can buy this on their website, and then you can just you buy the frame. Right now it's about $95 US, and then what you do is you check off all the different things that you want to go with it. Do you want a motor? Do you want ESCs? What do you want to add to it? And you end up getting a whole kit. So then these parts right here, so here's the carbon. This is what my goal is here, besides putting this thing together. We have all the parts that we need for layup. So here we go. So here's our pieces. So if we're going to make something like this, we don't, again, we don't have to copy this exactly, but if you're into the X style, H style frame, this is a pretty good one to go with, be it this or an alien or whatever. This is going to have to be pretty thick and rigid. So this, it's rigid. You can flex it a bit, but it's about as stiff as you could probably imagine. So what I think I am going to try to do is, if you could imagine, we're going to do a layup. Now, all composite layups, for the most part, you're going to oversize the product, and then you're going to cut out of that. And the main reason being, if I try to make a mold of just this shape right here, what's going to happen is carbon fiber is particularly slippery, and it frays really easy on the ends. And if I try to cut this, first off, if I try to even cut carbon fiber in this shape to put it into a mold, it's going to fall all to pieces, given it this skinny little piece right here. Even if I manage to hold it kind of together, all the ends right here are going to be less dense. The weave is going to start to come apart a little bit, and it's not going to be a good edge. When you go to cut this through or take it out of the mold, this edge right here, it might actually be square, really square, because of the mold you put it in, but it's all going to be epoxy resin. And if you dig that, then just pour yourself an epoxy resin mold. So what I'm going to do is I'm going to make a plate, and I'm going to do one with vacuum bagging. I'm going to do one with compression molding. Each has its differences, and ultimately I kind of feel like there's going to be a little bit of both kind of mixed in there somewhere down the road. But this plate is going to be obviously very thick, relatively, right, compared to most things. And you're going to have all this waste, and I'm not going into production with this. This is just a test to see how it works. Maybe if I want to make myself a frame somewhere down the road, what it would be kind of nice is if I could do one layup of a plate and get all these parts of it. The problem is this one right here is 4 millimeters thick. This one here is whatever, about 2.5 millimeters thick, and I believe I measured this one out to be about 2 millimeters thick. So they're all different thicknesses, and I don't want to do multiple different plate layups just so I can get some one-up parts in here. So I feel like what I'm going to try, and this could fail miserably, or I have an idea or have a thought that it's going to come out actually okay, but aesthetically it's not going to be so nice, because we're going to have our cosmetic layers to some degree up here on the top and the bottom, so it looks nice, and then the same with this and this. But what I'm hoping to do is if I take all these parts here and I kind of mash them into one plate, you know, like so, maybe, you know, something like this. If this is my whole plate for my milling operations, when I get to that, I can drill all these holes out, I can profile cut all this stuff here, you know, like normal, but this stuff here being thinner, I'm going to have to do probably an adaptive strategy to kind of get this milled down to the right height for each one of these. And of course, I mean, this is just a quadcopter. If I'm off by, you know, half a millimeter or something, or even a millimeter, it's probably not going to be that big of a deal. If I added a millimeter onto this, is it going to change the weight of the whole thing that much? That I care about it. I'm not pro racer, so that's not a big deal to me. Anyways, what I'll be able to do then, if that all works, again, not production, because the milling time is going to take, you know, substantially longer than just a profile cut. But what I want to be able to do is somewhere in the future say, hey, I want a new frame. Let's go ahead and just do a layup of, you know, 4 or 5 millimeters thick carbon fiber, smash it all down, let it cure, send it over to the mill, cut this thing all out, shave these things down to the right height, cut them all out, all the holes drilled, and then you're done. The thing that might be neat, if I were to ever decide to try to sell these, the only way I'd probably sell these is something like maybe little customs, or, you know, I have no idea. I don't even know if I want to say that. Anyways, the thought being that what if you milled this all out and you left little tabs behind here so it doesn't fall out when you're milling it, and the same thing with all of these here, but then you just leave it as is and you sell the product that way. And so I think that that's a pretty good model, assuming that the public or whoever's buying it understands that completely and is okay with the fact that they got to nip a couple things out of here and sand and polish to their liking, right? That way you can get, it can be a lot more affordable for both sides, I guess, right? The one thing that I talk about a lot is that when it comes to doing something production, I think most people that haven't made anything a lot or even tried to eBay sell anything, you know, at that level, they don't understand how ridiculously time consuming it can be to do a simple operation like cutting these things out of their, you know, the tabs, and then sanding that tab down. If you've ever milled anything before, you have any kind of a tab structure, it takes a fair amount of time. And this is critical, it's a human doing this. And there's different strategies. You can do other things on the mill to try to get the tab down as much as you possibly can, possibly do a profile cut, leave the tabs, and then the last thing you do is come by and do another profile cut, leaving that tab even just a tiny little bit more, you know, until it's almost ready to fall out. But still, you have to take a hand sandpaper or a .co or something like that, die grinder, and kind of smooth all that stuff out there. And you're introducing the human into the equation here, and odds are that you're going to screw up one out of every, you know, so many of these. At least, you know, the QA is not going to be terribly too happy with it. So that's the thing there. Takes time. Even if that comes out perfect and you just feel that you want to put a radius on this, and this one here is actually pretty sharp. They're not radiused or edge broke or anything like that. But and I find that in this case is fairly pleasing. But if you want to do that, then that's another amount of hand sanding that you're going to have to do, and that's insane. The thing that would be nice about a product, if you're trying to make and sell a product, this is what I like. Put this in the mill, it does the job for you, cuts the whole thing out, right? Maybe it took you 3 weeks to create the G-code and the toolpathing for this. So what? You know, once you get it, you got it, you push the go button, comes out here, does this thing. When it comes off the mill, the hardest thing you have to do is take it off the mill and stick it in the shipping bag and lick them, stick them, and throw it in the mailbox. That's the kind of product that I'm after here. Usually, right? When we're trying to compete with everybody else in the world that is so cheap. So that is the mission. Again, we're going to do a composite layup here, carbon fiber layup. It's going to be solid carbon fiber, and we'll do it a couple different methods, and then we'll go to, I'll show you my fusion model to kind of copy off of this, but then ultimately, you know, change it as we see fit, and then send it to the mill it down to right height, cut it all out, and then maybe wire one up and see how it goes. can see on here all the excess resin that came out. If you can see that there, it's not really thin. It's pretty substantial. So hopefully that means that we get a good light part. So here it is all kind of cut out. I'm not worried about making it perfectly square or anything yet because and I'm also not worried about trimming away the tape because I need to put this on the mill, and this will assure me somewhere to be able to clamp it down. I probably won't vacuum table this. All right, so heel ply now. So we have, everything's basically symmetrical, right? So you've got, you know, your inner stuff, your outer stuff, you know, the thick on the middle, the lighter carbon on the outside, and then we have the fiberglass outside of that, and then we have the peel ply outside of that. And then the next thing we're going to do is we're going to add the perforated film to it, but that's where the symmetry stops. Because the peel ply, the perforated film is here to help suck everything up into the breather, and you don't put the breather underneath either. You want the bottom to be against whatever surface it is to hold it down strong. If you put the breather in, it starts to create kind of like a mattress or something there. It's squishy, right? And so if you want to have a really flat surface, you're not going to get that if you put that on the bottom. And also, if you thought, well, hey, I'll just be extra heavy-handed with all the resin in here, and I'll just add 3-4 layers of bleeder cloth to suck it up, then on the top, you're not going to get a good pressure on here. You're going to have a whole stack up of this stuff here. So think about this. I got this stacked up like this, and now I start mashing down on this. How much force can you get on this now? Because this is all squishy, and it's, you know, trying to smash your brother with a mattress. Okay. Now the perforated film. And this doesn't need to be wetted up. I'm just straightening it out. So I trimmed it all out to fit on this plate. I could do it right to the table, but this plate is a bit stronger, and the vacuum is actually strong enough to where it pulls the, I've got just some sheet metal on top of all these tables here. It'll actually pull the sheet metal up off the table, kind of contract it up, and so I don't want that to happen. Also, this becomes more portable and I can move it if I need to. So this is sealant tape. Get this from, well, ACB Composites, but it's probably from AirTech ultimately. So I'm going to take this, I'm going to run around the perimeter. Now, in the course of cutting this out, I got a little bit of resin around here. It may or may not be a big deal. I can say it's probably not a big deal right now, but I have to put the tacky tape down first. Leave the paper on, by the way. And I'm cutting it extra long. Here, I'll show you down here to see. So I cut this there, kind of extra long, because what's going to happen is my vacuum coupler is going to go over here. You can't put the vacuum coupler right in the middle of the part because it will smash the crap out of it. It'll embed itself right into here, so it needs to go off to the side. And if we think a lot of resin is going to come out of here, like I kind of suspect it's going to, we're going to probably even put it out there, because now that I say this out loud and I have the room on the plate here, I'm going to extend that tape out a little bit more, and I'm going to stick the foot like way over here. So that's to give it a lot longer path for the resin to try to find its way to there, because all that coupler and everything costs a fair amount of money, and you don't want to get resin sucked up inside of it. There is a technique where you just sort of bend this, break the paper, and bend it around the corner. I don't do that. Don't pull in this when you do that. Cut it, don't pull it and break it. So I don't know if you can hear that or not, but you can see we're about 22 or so, and we have a lot of hissing. So you start going around to all the pleats right there. There's a big one. Gauge goes up. There we go, there's another one. So you check all of your corners where the tacky tape overlaps, and of course all your pleats. You could give that a little twist. That might be a problem. Watch for any wrinkles getting underneath there. Corners, all the corners. Oh yeah, look at that. Now you start seeing the resin come up and through.